Imagine a next generation AI data center containing thousands of GPUs. And as AI computing grows, the power required by each rack of this GPU is increasing rapidly. And that is why industry is now shifting to high voltage DC distribution architectures, including 800 volts DC systems intended for the future megawatt scale AI computing racks. As the high distribution voltages of around even 800 volt DC allows the same amount of power to be transferred at a lower current, and that's why having the lower heat and the losses. But it also creates a critical protection related questions for this high voltage DC distribution systems. What happens if a short circuit occurs on a DC bus which is powering a highly expensive and power hungry AI rack? The fault current can rise exponentially in a very short amount of time. And unlike the AC distribution systems, in which the AC current crosses through the zero at every positive and negative cycle, in the DC distribution systems, there is no such case for handling the DC currents. That's why in DC distribution systems, if short circuit occurs, the DC current rises exponentially, and we need a very reliable mechanism to handle the short circuit DC currents. The protection systems in the DC distribution must detect these faults, interrupt the high DC current, and isolate only the affected branch before the disturbance spread through the wider power distribution system of a DC. And that is where the solid state circuit breakers, in short SSCB, enters in the picture. And SSCB is not just a mechanical circuit breaker with MOSFETs replacing the mechanical contactors. It is a coordinated, smart and intelligent protection system with the power semiconductors, embedded control, fault energy management, isolation and the industrial communication. And in this video, we are gonna deep dive into this technology of solid state circuit breakers. Why is it becoming important, and an overview about its complete architecture. And to all of you, a technical reference I want to give is NVIDIA is developing an 800 volt DC architecture for future AI data centers with the stated objective of around 1 megawatt of IT racks from the beginning of 2027. And this is a future architecture in which the industry is gonna shift, even though it's not a stated mandatory standard, but it's an architecture onto which the industry is gonna move and adopt. And the same DC protection challenge exists beyond just the AI data centers. You take the battery energy storage system industry, in which we have the DC battery packs, DC racks, power conversion systems, and the DC bus, which needs to be protected from the DC faults and the short circuit current. Another industry is of the EV charging. Fast EV chargers of around 400 volt DC or higher need to protect the EV charging stations and the battery packs of the vehicle with the same DC overcurrent or the short circuit faults. Another industry which is rapidly growing is of DC microgrids, which contains the solar generation, wind generation, then power converters, batteries, and the multiple complex connected loads connected to the same DC distribution network. These applications are different, but the problem that needs to be solved in the DC distribution, in the DC high voltage distribution or the electricity generation, is of the DC fault current and the short circuit currents. And that is exactly where solid state circuit breaker enters into the market. Before deep diving into the solid state circuit breaker, let's deep dive into the traditional circuit breakers, the mechanical circuit breakers, which are being used traditionally as if now, and how they work at a surface level and their contrast with respect to the solid state circuit breaker, so that we can get into the understanding of architecture. During normal operation, mechanical circuit breakers keeps the two electrical contacts closed, allowing the current to flow through them. When an abnormal current is detected thermally, magnetically, or the electronically, a control trip mechanism releases these moving contacts. And as these contacts begin separating, a physical gap is maintained between the current path. But the current between these two paths doesn't stop as the contacts start separating with each other. And as this gap increases, the electric field between these contacts can ionize the atmosphere around it and can create an electric arc. And the breaker must control, cool, and finally extinguish this arc before the current is completely interrupted. In an AC systems, the traditional AC distribution network, the AC networks, or the AC mechanical circuit breakers, the AC current naturally crosses the zero at every positive and negative cycle. So this natural current zero helps the breaker extinguish this arc. But in a DC system, there is no such thing. There is no periodic natural current zero in the DC systems. So it's the responsibility of circuit breaker only to force the current towards the zero and also manage the energy which is stored in the electric field that is being generated by separating of the contacts. And that is why this makes the high power DC interruption particularly challenging. And that's why, as with the rise of DC distribution and the DC high voltage DC electricity, the challenge in the DC protection is being rapidly taken notice by the industry. So the purpose of solid state circuit breakers is not to replace the mechanical circuit breakers, but the solid state circuit breaker is to fill those areas, those applications where that kind of speed, control, and the system integration can't be fulfilled by the mechanical circuit breakers, and that is the uprising of the DC distribution and the DC network. So now we understand how a mechanical circuit breaker works and it interrupts the fault, and this architecture is being used for decades in our electrical power system. But now, as our electrical power system is changing towards DC microgrids, battery energy storage systems, fast EV chargers, and the AI data centers, the protection requirements are changing as well. So the next question is, can we interrupt the DC fault currents electronically without depending on the mechanical contacts? And that is the answer given by the solid state circuit breakers, which is being built by the next generation of power silicon chips like of silicon carbide or gallium nitride GaN chips. So in the next video, we are gonna deep dive into the architecture of solid state circuit breaker and gonna deep dive into its important functional blocks and understanding those functional blocks from the mapping of silicon chips and the solutions which are used. So till then guys, don't forget to subscribe this video and share this video with your friends who are more interested into the upcoming technologies coming into the industry of AI, data centers, power energy, and what all.